Good afternoon.
Ongoing war has triggered a domino effect of ecological devastation, threatening both the survival of its people and the environment. The city depends on the aquifer as its main source of water, catering to both human needs and agricultural processes. Reduced rainfall due to climate change and excessive groundwater extraction from overpopulation has put pressure on the aquifer, resulting to water shortage and seawater intrusion. Military operations continue to contaminate the ground as Human Rights Watch reports that white phosphorus has long-lasting effects,
Penetrating soil, destroying ecosystems and vegetations for years. Destruction of essential infrastructure has intensified the situation further. According to the UN Environment Programme, 60% of wastewater treatment facilities have been destroyed, and due to limited resources, materials, and restricted movements, around 70,000 tons of waste have piled up in makeshifts. With an alarming rate, land devastation and wastewater systems collapse. We have an ecological emergency expected to persist for generations. How do we then imagine the future of Gaza? Emerging from Gaza's ravaged landscape, this vision for reconstruction transcends physical rebuilding. It introduces a new building typology that heals the land and fosters placemaking, allowing people to reclaim their lives, culture, and hope. Architecture serves as a tool for resilience and identity, challenging colonial narratives while restoring ecological and social bonds. Through community strength, we reimagine Gaza as a place of renewal, where architecture leads to restoration of water, soil, and sky. Today, we explore the deep connection between architecture and ecology in shaping sustainable urban futures. Architecture actively engages with challenges like climate change and resource depletion, emphasizing its responsibilities beyond technical solutions. We view the land as a vital element of architecture, underscoring the need to integrate building culture along with ground culture by dismantling barriers between built and natural environments. We make soil and water health cornerstones of our approach. In this way, architecture becomes a regenerative force, nurturing ecological resilience and fostering coexistence between human and natural systems. Wadi Gaza is an essential seasonal river that recharges Gaza's coastal aquifer. However, it faces significant challenges that have degraded both water quality and soil health. In 2019, the UNDP plan proposed a master plan for its rehabilitation. Based on that, our proposal presents an alternative approach that links Gaza's infrastructure reconstruction with environmental rehabilitation, emphasizing ecosystem regeneration. Key questions we explore: how a low-tech material system reinforces intersections of public placemaking and remediation processes for wastewater and soil treatment, using local compressed soil blocks fabrication and enhancing awareness to foster shared sense of ownership in the public infrastructural facility. We focus on 3 intervention levels: natural systems, system design, and participatory design, to propose a whole ecological system. The individual elements of the systems lie with each other in a feedback loop, affecting one another.
The scope of the thesis encompasses the design of interconnected urban networks, emphasizing wastewater management, agriculture, and constructed wetlands, integrating systems that operate underground, at ground level, and at ground level and above ground. At a regional scale, the thesis emphasizes site regeneration by integrating designed urban networks within a regenerative system that connects cultural landscapes and constructed wetlands. Material research and design focused on utilizing local materials and employing compression techniques for the production of building bricks and fabrication techniques. Rethinking public building typologies to incorporate wastewater treatment plants, composting facilities, and communal spaces while addressing the cultural needs of the community. This approach fosters placemaking through educational, communal, and economic programs. Focusing on a natural system that integrates agriculture, water, and soil. The design of wastewater networks align with needs in wastewater production, irrigation, rainfall recovery, and groundwater usage. This assessment led to plans for 2 treatment plants, one as a replacement for the destroyed facility and another as a new addition. Wetland construction volume was calculated based on catchment area, runoff, and rainwater. Rehabilitation efforts around Wadi Gaza include composting processes with assessments covering the soil volume for remediation, raw waste capacity, planting density, and composting requirements in a 5-year land restoration plan. We begin by examining the broader global framework for urban network development in Wadi Gaza. First, allocating wetland bodies based on the natural terrain and water flow dynamics. Second, optimizing the underground wastewater collection system to support these wetlands. Lastly, we're working on enhancing the agricultural infrastructure to integrate with both the wetlands and the wastewater system. Our wetland experiment aimed to determine optimal size and location based on water flow patterns, targeting stormwater capture, and directing treated wastewater to recharge the valley and the aquifer. We evaluated rainfall, elevation, slope, and runoff, placing wetlands in low-lying areas away from residential zones, with buffer zones to protect wildlife and public health. A meandering network was designed to slow water flow and enhance management. Using multi-objective optimization, we minimized network length, ensured appropriate slope, and maximized inlet-outlet distances to confirm water flow. Connecting the global network from the regional scale down to the local level of the selected site.
The site is located along Wadi with the main road passing over. The network begins with the treatment plant and 2 ponds. An evolutionary algorithm was set up to minimize the material for the pipes, maximize pond volume, flow of water towards the ponds in accordance to the slope and the spiral of the nodes. Slope and elevation determine the points of the location of the treatment plant and ponds. Next, we provided the required area around the WTP node, offset along the wadi for erosion protection, and set the composting zone according to prevailing winds. The plots for the public programs were generated central to different functions with target buildable area and relative distances to the main functions as objectives. Final configuration of the site regeneration was finalized with composting areas, wastewater areas. To facilitate effective site regeneration, the system connects treated wastewater to ponds, which replenishes the wadi and strengthens the wastewater network. The experiment aimed to optimize the flow of wastewater utilizing slope and elevation to ensure efficient water movement. The design of the wetland system involved determining the spatial configuration of the wetland surface while adhering to established standards for water flow, buffer zones, material types, and vegetation. The selected vegetation included aquatic microphytes that play a crucial role in the water purification, comprising rooted plants, partially and fully submerged species, and floating varieties in deeper areas. Site zoning. On a local scale, the constructed wetland was designed to direct water towards the valley from a single outlet, maximizing purification through increased plant contact. Comprehensive water flow and slope analysis guide the selection of the points for the sedimentation pool, which was designed with a slope between 0 and 1.25 to promote sediment retention. Site zoning around the wetland was informed by project findings and contextual design consideration. A 15-meter buffer zone was established to ensure safety with supporting wildlife and habitat conservation, alongside a 30-meter inner buffer to facilitate water flow and prevent blockage, allowing for effective maintenance between buildable areas. Finally, refinements were made to the development areas and buffer zones, including the design of a sedimentation pool that retains 5% of its treated water and clean pools. Zooming in, the detailed constructed wetland design. The forebay serves as inlet for the water from both the wastewater treatment plant and stormwater. The water flows through the low and high marsh areas gradually, moving towards the clean water deep pool. Both the clean pools with the constructed wetland receive the filtered water from the wastewater treatment plant, enhancing overall quality and dispersing the water towards the valley through an outlet point. The wetland cover a large portion of the site, offering stormwater treatment, habitats for wildlife, and enhanced spaces for community enjoyment. This close connection fosters educational opportunities, a sense of shared ownership, and a deeper bond with the land. Taking a sectional approach to Gaza, we focus on building from ground up through an integrated regenerative design. By dispersing infrastructural spaces around public programs, we create a fluid transition across the site, blurring boundaries between built and natural environment for a seamless, immersive community experience.
Looking at participatory design, addressing material limitations while leveraging local resources, we studied existing building techniques and architectural goals, aiming to develop water-resilient, thermally insulating, scalable, and easy-to-fabric materials that encourage community participation. The material development aims to create a foundational building solution inspired by Gaza's traditional loam architecture. An assessment of vernacular construction methods showed that enhancing loam's effectiveness required both an additive and a stabilizer. However, natural additives often have competing industrial uses, and unnatural stabilizers raise environmental concerns. CSEB is a very well-known technique used by 67% of the population, with easy assembly, which uses lime and cement as additives. The project uses the abundant agricultural palm tree in Gaza, but underutilized date palm fibers to improve loam's adhesion and strength. Magnesium oxide, a natural stabilizer from desalination brine, hardens the mixture by absorbing CO2, making it a carbon-negative solution. 4 experiments were conducted to find the optimal ratio and strength of the material, each identifying the best combination of the binding materials, which were further used for the next trials. Compressive, tensile strength, and water resiliency assessments reveal that the material could achieve a maximum compressive strength of 1.05 MPa. And in order for a sustainable cycle, crushed blocks can be easily reintegrated into the soil, ensuring that the land and its resources continue to support the community. The research links material experimentation to morphological fabrication, focusing on brick design that supports the compression studies inspired by the vernacular techniques grounded in principles of friction and bonding. A simple physical mode was developed to streamline the brick production process, enabling the community to manufacture them with ease. We focused on integrating public infrastructure with community spaces to foster communal interaction and placemaking. A weekly schedule for activities in our facility was established, prioritizing educational workflows, cultural classes, and recreational events that encourage community engagement. The infrastructure supports community-oriented programs, including indoor play areas, creating a cohesive environment that promotes environmental restoration and raises community awareness. Utilizing research and programmatic needs, we developed a space quality assessment matrix to effectively organize and connect these programs. Utilizing existing research and programmatic needs, we developed a space quality assessment matrix to effectively organize and connect these programs. The spatial allocation and integration of programs were determined using computational algorithms for form finding and structural stability. This approach incorporated solar radiation analysis for fenestration design, optimizing light requirements, thermal comfort, and water flow assessments. The building typology was further refined to include detailed fabrication, construction, and architectural elements, facilitating ease of community participation. A key aspect of the program's future development is ensuring easy access for the community, allowing for a seamless integration of each phase. This approach not only enhances community learning, but also fosters participation in the building process. The app that we developed introduces users to the project's vision, the designers, and the innovative materials being utilized, all with a user-friendly interface. Once configured, they can visualize the building in real-world AR scene, A simple tap provides a step-by-step guide to the building process, transforming it into a hands-on, enjoyable experience. We are continuously enhancing interactive features to redefine how communities and projects connect, fostering a collaborative and educational environment for all. This proposal addresses the ecological, social, and environmental crisis, as well as establishes a framework that empowers the community to rebuild, focusing on improving human living conditions and restoring the vital elements of water, land, and sky, thereby giving voice to the people and narrating their stories through a resilient landscape of a city that has endured profound destruction. Thank you.
Do we have any questions?
Thanks. Thanks, guys. I had one question. I don't know how it works in the Gaza Strip, but in the UK, a project like this crosses boundaries of the environmental agency, the water treatment plants, the ground associations. There's highways that are going through this. There's educational programs in this. There's public spaces you were creating through this. So there's a lot of different organizations that would have to be involved in this. And I was kind of wondering how the structure is there and how those different groups might be, how you thought about these different groups engaging in this project.
So basically, we've been in contact with Architects for Gaza, and they've been working with short-term projects considering hospitals, schools, and houses. So our proposal is linked to a short-term solution with them. The second phase is constructing the fast processes of remediation with the locals. Third is with the UNDP, since they already worked on the rehabilitation proposal, considering open spaces, considering the rehabilitation of the Wadi itself, so their scope is a bit similar to us. So I think the UNDP is the best organization to go with this project if we're going further with it.
Thanks.
Thank you so much for presenting and also bringing forward some important issues that needs to be discussed. So I was wondering, in your presentation, which was quite thorough in a way that it jumped between scales, so you talked about the ecosystem, but you also specified which sorts of plants, that the vegetation, the specific type of vegetation. And my question is, do you see this project kind of expanding onto a larger scale? And because you were creating systems as part of your design, does that have an implication of possibly expanding beyond your site? Or?
Okay, so this is the MSc phase of our project, and we are currently, Ashna and I are working on the MArch phase. We're planning to extend the timeline that we're tackling. So let's say MSc phase lies in 20, 25 years from now. And in the future, we're planning for food security. So how can we possibly engage all of these systems together? The composting, wastewater, we're now introducing potable water as well, power, infrastructure, etc., in order to have a self-sufficient community. So that is the, let's say, 50 years plan from now. And we're currently working on it. We will be presenting it in January. Maybe you'll be here.
Any more questions? Yeah.
Actually, I wanted to follow on from your question, because I think it's a really interesting project, and you can kind of see in the horizon that your project just kind of ends. And I was kind of curious I know that you still haven't worked on it, but I kind of imagine, have you thought about what the surrounding of your plot might be like, and how, because you're talking about also it has educational programs, so I'm curious then, not only what you think might be around your site, but then also how the things around your site might be affected by you, so their interactions with your site, and then also how the techniques you've used might affect those buildings around your site.
This project was, as May said, around 15 to 20 years in the future, and the MArch phase is actually tackling a bit behind 15 years, so let's say like in the next 2 or 3 years, where we're actually looking at camps that are right alongside the site itself. So for what the camps really do require at that time would be a lot of amenities like schools and clinics and all of that. And our project allows the people to be integrated with the project itself. So we're actually pulling the people from the camps, giving them a sense of ownership and allowing for placemaking. So it doesn't become something that is separate, but it becomes a part of them.
And also, like, after all of the destruction, we're not looking at the ground level, at the land as a tabula rasa. We're not looking at that because we want the people to come back to their lands and to construct. So we're not forcing an image for the surrounding environment. So we're not looking at this land as it's like our own. So we're giving voice to the people also to like empower their narratives, how their lives were. So it's a whole research domain to design that area in the long term.
Thank you so much for sharing, guys, also bringing light into this, as Palin said. I wanted to ask about, or maybe if you have any sort of alternative plans about, because when people start, I initially really like the sort of little clusters in the landscape, because it allows for almost gives you a vision of how can materials sort of blend into each other as communities come together, and almost the communities knit these spaces together. But then also the material that's found or retrieved from the land, sort of processed by people, they are eventually going to keep changing as the land is also built on. So do you have also any sort of ideas of what the structures or the forms of the structure might look like as people keep adding on to it?
Can you repeat the question again?
Like, do you see it in the future, for example, these forms, these clusters coming together and finding another sort of an alternative vernacular of the place, sort of reflecting people's memories and the way they interact with the land as well?
So let me get this straight. You're asking about the structure as it is right now, so in 30 years from now, and how are people gonna interact with it? Contrary to the vernacular.
Yeah, or what it might look like, because the forms are super specific to your research right now.
Yeah, so we know that this is a very, like, it's a way forward morphology, and obviously what's happening now in Gaza won't allow this to happen right now. We understand that it will take 30 years to come up with the whole system. That's why we can show it again. We have a process that the community can follow. So we're wooden scaffolding, and then we are using the very basic brick that can be done by the community. And then step by step, they can form these volumes. Other thing, we are currently now working on, let's say, a simpler version of what we propose in MSc to tackle the first phases, which are let's say in 2 years. We will be using basic local materials so that you have the scaffolding here in 30 years, but it has to be done in step-by-step way. So like first phase would be to use local materials to build basic structures, which could be basic boxes, and then those two boxes or volumes can be put on top of each other, and then forming the scaffolding, which you can see in the picture here, and then finally building the bricks on it. I don't know if I answered your question.
I think I would like to add a few more things. So recently, the architectural practice in Gaza, it's mainly focused on bricks, on concrete bricks, and concrete and steel, and there's a limitation of material exportation. So we're trying to give an alternative method of building, which they can further develop through the future. So for now, we worked on a long-term structure, which is the catenary arches. But later on the timeline of rebuilding, there should be a temporary structure, first of all, to promote the rehabilitation and the processes of remediation. And then further on, this gets built into the catenary arch. But this is not the only solution. As You give the people the way of building and the know-how, and you teach them. Then you give them the opportunity to further expand because they have the expertise. They have architects, they have students which have the expertise and knowledge, so they can take this further on. So we're laying the foundation, the base of the material, of the system, of the processes, of the whole ecological system remediation, ecological regenerative design, in that sense.
I can add one more thing. As Afaf said, we're going from temporary to permanent, and maybe not on that scale, but we are teaching them from an early on phase. So in 2 years, they're gonna be knowledgeable through our app and through our process. They're gonna know how to build a basic unit that further on can become this in 30 years.
I hope we answered.
Hi guys, I have a small question. Do you talk about all this ecocide and how I think we all understand a little bit of how the destruction of all the ecology. Have you measured or are you going to plan to measure any of these indices on how your project is going to change, like the systems, the ecological system on a larger level? Or have you done that? Like, because you are talking about all this like ecosystem that you are creating, but how is it actually changing on a quantifiable level?
So we acknowledge that climate change is affecting a lot Gaza since it's on the Mediterranean Sea and there's reduced rainfall. So our system is tackling the wastewater treatment plant, which provides treated water throughout the year, despite of what's happening with the climate change. So that's one, let's say, variable that we're trying to control since we're working with constructed wetlands. So we're trying to feed the wetland all over the year, since there's reduced rainfall. And through the ecological system, the ecocide and the contamination and the seawater intrusion with the valley is increasing throughout time. So we're trying to tackle the wadi as a whole area, which is spanning from the east to the west. And that whole system, if you're trying to regenerate it, rehabilitate it, it will affect also the aquifer, which is the main source of water, the main source of the ecological system. So we're trying to, first step, provide water. Second step is to rehabilitate the wadi. And third step, which is a really long run, is to recharge the aquifer, which will benefit the whole ecological system. So it's a step by step for the future.
And the main thing also is that along the wadi, you have a lot of agricultural fields as well. So along with recharging the water and the aquifer, we're also looking at how can we rehabilitate the soil. So our project does establish a composting system within this step also, which allows the soil to be rehabilitated, which allows a lot of agricultural fields to grow ahead. And our last and final step, which we would be doing in the MARC phase, would be food security. So when you combine it all together, this is how we're planning on tackling the entire ecocide.
And to answer the quantifiable part of your question, so all of our data was based on quantities, on rainfall, irrigation, the soil quantities, which is not precise for the soil as it is, because we don't know the depth, which needs experiments. But for that, we calculated the area that we want to treat for this timeline. We calculated how much compost we need, how much wastewater, treated water we need, and from there we calculated the needs and the programmatic functions for each of these facilities that will tackle this ecological problem. So further on, these same calculations will be made with time in order to expand.
Thank you for coming and sharing this all-encompassing and sensitive project. My question is, how do you approach rehabilitating soil? I'm really interested in.
So we had actually collaborated with someone who, I forgot the name.
Jeremy.
Yeah, Jeremy. So he is someone who's an expert in soil and understanding rehabilitation of soil in mostly war zones itself. So a lot of the pesticides and white phosphorus and a lot of the other destructive materials that I found in the soil can be rehabilitated using a very simple process, which is just composting. So you need time for the soil to compost on itself. You just need to get all agricultural, very simple methods. You get like agricultural waste and you just compost the soil using that, which in the next 10, 15 years would allow the soil to regenerate all by itself. We do not need to add any extra materials in it to do that.
Also, it's the integration between the wetland processes and the agriculture and composting. So the water is part of the rehabilitation of the soil itself because it's interconnected. And the second thing is about cleaning one batch of soil through composting, through agriculture production, and chop and drop. So you plant some trees, you chop them, and then the composting process goes along, and then you transfer this part of the soil towards the area where you want to have agriculture production, and then you repeat the process. So it's an ongoing process between soil remediation and water rehabilitation.
Thank you. Okay, if there is no more questions, do you have a question? Okay. Yeah, thank you everyone for coming, and thank you again for presenting and being here. Today, later on, we also have another guest that comes to Front Members Room at 2:30, Yesmeg Joel. He works with Urban Harvest to make public spaces from wood. We hope to see you all there as well. And yeah, thank you.
Thank you so much.
Thank you.